All right, this is 7.2, solving systems of equations using elimination. Okay, most algebra students prefer this way because it's a little bit easier than doing a substitution. In this lesson, you will solve systems of equations by elimination of linear equations. In this lesson, we're not going to be dealing with those conics because we want to be able to just add them together. And we're going to use the system of equations to model and solve real-life problems. Okay, let's look at this problem here. From Algebra 1 and Algebra 2, you know that when you see two coefficients that are going to cancel each other out, like this positive 2 and negative 2, you can go ahead and just add the two equations together. You're going to add the 3x and the 5x, get 8x. And these go away because they become 0y. And 4 plus 8 is 12. Solving that for x, I get 3 over 2. And then putting it back into either one of these. It doesn't matter where you put that in. And I'm going to put it in the first one. So now I have 3 times, put that in parentheses, 3 over 2. So that will be 9 over 2. So I'm going to get a common denominator on this side and make that into halves. So we've got 9 halves, and now we have 8 halves, which is 4. And then subtracting the 9 halves from both sides, I get negative 1/2. Dividing both sides by 2 or multiplying by a half to cancel that 2. Okay, or you can say dividing both sides by 2 if you want. Then you get negative 1/4. The reason why I say multiply by 1/2, some of you have trouble dividing a negative 1/2 by 2. Okay. But this is what dividing by 2 means, multiplying by half. So now we have x and y. So my final answer is 3 over 2, comma, negative 1/4. All right, try this one if you can remember. If not, then you may want to watch. But I think you can do it. Okay, we don't have anything that cancels. The 5 and the 2 don't cancel. The 3 and the 4 don't cancel. So I'm going to either try and make these, the 5 and the 2, match up with 3 and 4. Since this is already negative and positive, since the signs are already opposite, I'm going to do the 3 and the 4. I'm going to multiply this one by 4, and I get 20x plus 3y is equal to 36. And I get 2x minus 4y is equal to 14. Multiply that by 3, and I get 6x minus 12y is equal to 42. The reason I multiply by 3 and 4 is so I can make these 12s, positive 12 and negative 12. Now I can go ahead and add those together. I get 26x plus 0y is equal to 78. Divide both sides by 26. I get x is equal to 3. Now I can put this back into any one of these I want. And it doesn't matter where you put it in, but I find the one with the smallest numbers because it's easiest for me to do in my head. 3 times 2 is 6. Subtract the 6 from the 14, and I get 8. And negative 4y is equal to 8. So y is equal to negative 2. So my final answer is 3, negative 2. Just a quick reminder, these are all linear equations. How many solutions are you going to expect to find? Well, they're either going to be 1, but not more than 1, right? Okay, so you can have one solution where the lines cross, infinitely many solutions where the lines are on top of each other, where they're actually the same equation, or if they're just plain parallel, then they will never touch and we'll have no solutions. So either have none, 1, or infinitely many. Okay, that's something you're going to have to make sure you pay attention to when you're solving these. And don't just crunch numbers and go, I got the answer, or no, I didn't get an answer. All right, the answer for this will look like this. The answer for this is when you're solving it, you're going to get 9 is equal to 9, or 5 is equal to 5, or x is equal to x, and you know that it's going to be infinitely many. And if you get something weird like this, 9 is equal to negative 4, it's no solution. Now let me put a little warning here. Okay, when you do things wrong and you get something weird like this, you put no solution, there are not going to be a whole lot of no solutions on your test and your homework. So don't go putting no solution everywhere just because you did something wrong. Okay, so make sure you double check. If you get something weird like this, go back and check your math. Maybe you made a little math error somewhere. All right? Okay. Now, let me talk about problems like this. You look at this and you go, oh, that looks so ugly. This is really not that bad if you realize that you can multiply by something on the whole equation and it won't affect it. So how about if I multiply both of these by 100, just move the decimal over twice on each one of these, and it cleans up really nicely. So when you see something that looks like this, you may just want to multiply by 100 or 10, however many decimals over here that you need to move. If you need to move it twice, multiply by 100. If you need to move it once, then multiply by 10. All right. Real life problems. A plane flying into a headwind. This plane flying into a headwind. The wind is blowing it, so it's going to fly slower. 2,000 miles from Fresno to Cleveland in 4 hours and 24 minutes. On the return trip, it's going to go the same distance, but it only took it 4 hours because now instead of the wind pushing it back, the wind is helping it, so it's going to go faster. So it only took it 4 hours. It saved 24 minutes. Okay, so we're going to set this up, and if you're going to start using variables, then you need to tell yourself what the variable means. P, I'm going to put the speed of the plane, and W as the speed of the wind. Okay. On the way there, the wind is going to be pushing on it. So if this plane is going 500 miles per hour and the wind is blowing at 100 miles per hour, the wind's going to be pushing it back, so it's actually going to be going 400 miles per hour. And on the way back, it's going to be going 600 miles per hour because it'll be the 500 that the plane's going plus 100 miles per hour that the wind is pushing it. Okay, so that's the setup for the problem. So now we write ourselves an equation. On the return trip, it's going to be the plane speed plus the wind speed because the wind is helping it, right? That'll be like 500 plus 100 is 600. And on the forward trip, it's going to be the 500 minus the wind, so it's going to be P minus W. Those numbers, the 500 and the 100, I just made those up. Those are not the real answers. Okay, I just made up some numbers so you can understand what I'm talking about. So now we're kind of ready to solve this. We just need one more component of this that you may have trouble with, and that is these are speeds. Okay, and we have miles and hours. And we know that speed is going to be measured in miles per hour. So we can say that we're going to take the miles and divide it by the hours. This will give me miles per hour. If that makes sense to you. So we have 2,000 miles. It took us 4 hours. That's going to be 500 miles per hour. That makes sense? All right. That is equal to the speed of the return trip. Now, how do we deal with that 24 minutes? We know that there are 60 minutes in an hour, so we divide the 24 by 60. So it's the 4 hours plus the 24 minutes divided by 60 will give me 0.4 hours. Add that to the 4 will give us 4.4 hours. So now we have 2,000 divided by 4.4 gives me P minus W. Okay, the plane speed minus the wind speed. Now just divide these out, and I get 4.5, that's this one, and then the 500, and I'm going to add those together by elimination. This is already lined up for me nicely, so I can add those together, and 2p is equal to 954.5. Divide both sides by 2, and I get the plane speed is 477 miles per hour, 0.25. Okay, that's the speed of the plane, the actual speed of the plane. So the speed of the plane is 477.25, and the wind must be the difference of that from 500. So the wind speed is 22.75 miles per hour because the sum of them is 500. Okay. So find the airspeed of the plane and the wind, so there's my answers. Always look back at the question to make sure you've answered the question being asked. Mixture problems. When I was teaching Algebra 1, mixture problems was a real difficult thing to teach because they could not get their mind around this kind of adding percents and things like that. So we're going to set this up step by step. 20 gallons of a 12% solution is obtained by mixing a 10% and a 15% solution. So we're mixing two things, a 10% and a 15%, to get a 12%. We're mixing them. So this one's a little bit less concentrated, this is more concentrated, and we're going to get something in between, right? When we mix them, we're going to get something in between 10 and 15, which is, in this case, 12. We want to know how much of these we need to mix to get 32 gallons. So we have a 10% solution plus a 15% solution is going to be somewhere in between. We're going to dilute or concentrate this one or dilute this one to make a 12%. Altogether, we have 32 gallons. So far, so good? All right. And we don't know these two, so we're going to say that this is X gallons and Y gallons. Okay. Now, the concept here is that we're going to keep track of the gallons. So we have X plus Y equals 32. That's how much in here. How much in here is equal to this over here. Now, there's some other thing in here. We're going to keep track of the salt. 12% of 32 gallons is salt. So there's some salt in here that got mixed up with this. I'm going to assume it's water and salt. So the salt in this solution is going to be 12% of the 32. So 0.12 times 12 gallons, that means I really have 3.84 gallons of salt in here that was mixed with that whatever liquid that I had to mix it with. So using the same notation for this, how much salt is in here? Well, 10% of the X gallons is salt. So that means is 0.10 times X is how much salt is in here. How much salt is in here? So that will be 0.15 gallons of salt times, 0.15 times Y gallons. That's how much salt is in here. So if this much salt in here, and this much salt in here, and this much salt in here, all together, we should be able to add them together and get equal, right? The amount of salt here plus the amount of salt here has equal to the amount of salt in this one. So we've got 0.10x plus 0.15y is equal to 3.84. And I don't like those decimals, so I'm going to multiply that by 100 to move the decimal over twice. So I get 10x plus 15y is equal to 384. Well, if I'm going to do this by elimination, I want something in here to cancel one of these. I'm just going to go ahead and multiply it by a negative 10. So I'm going to get a negative 10x minus 10y is equal to negative 320. Now I can do the elimination by adding these two together, and I will get 5y is equal to 64, which means that y, dividing both sides by 5, y is 12.8 gallons. Okay, now we need to find how many gallons is X. So we're going to put this back in here for Y, subtract that from 32, and I'm going to get 19.2 is my number of gallons for X. So you may have to watch that again. I'm not sure, but that's how you do that one. Okay. Investment. Even though this may look completely different, this is really the same setup as the last one. We have a total amount of $450,000 is invested in two corporate bonds that pay 7% and 5.5% simple interest. Just a little side note of how investments are paid. The more risky the investment, the more they have to pay you to invest in them, because you might lose your money. The investment may not actually pan out. So that's why you have two investments. One is at 7%, one is at 5.5%. You would think, why don't you just put all your money in the higher interest one so you can make more money? Well, there's a chance that this company that's paying you more money might go broke, so that means you want to spread your money out. In investment terms, they call that diversifying your investment. Spread it out so you don't lose it all in one place. Okay? Don't put all your eggs in one basket. That's what they say. Anyway, so you're going to have some amount of money at 7% and some amount of money at a different amount at 0.05 or 5.5%. And then all of that is going to be $450,000. So you have X dollars and Y dollars is going to equal 450,000. So some part of your investment you're going to leave here, some part of your investment you're going to leave here. All right. So here's my first equation. Some amount of money plus another amount of money is going to equal 450,000. Now we're going to keep track of our interest. We know that it says here that you made $27,000. Well, you made that from here. All right. So 0.07 times X is how much you made from here, and 0.055Y is how much you made from here. So adding these together, you're going to make $27,000. So that's how you do that. Now I don't like the decimals here, so I'm going to move it over. So I need to move it over twice here, but I want to move it over 3 times here. So I'm going to multiply everything by 1,000. So I'm going to move the decimal point over 3 times on everything. So move the decimal over 3 times on here. 1, 2, I need to add another 0. 1, 2, 3 over here. And then I have to add 3 more zeros on the 27,000. Now, so that I can cancel them out, I'm going to multiply the top equation by one of these variable coefficients. I multiply by a negative 70. So negative 70x, negative 70y is equal to a negative, let's see, looks like 31,500,000. Okay. Do my elimination, cancel the x's. I get a negative 15y is equal to negative 4,500,000. Dividing by a negative 15, I get 300,000 is how much I have in my y investment. So if this is 300,000, then that means on the x I have to have 150,000 altogether, making 450,000. So always look back to see what the question was. What is the most that you can invest in this amount? Okay, the most I can invest is 300,000, because if I invest any more, I won't make my 27,000. Okay, because this is what you want to make. If you invest more here, you're going to get less money, because this is going to be, it's going to make you more money if you invest less here. If you put too much in here, you're not going to be able to make 27,000 because you're investing more in the one that's paying you less. Okay, hope that makes sense. All right, one more. 200 tickets were sold for a basketball game. Tickets with an ASB card are $5 and $8 without an ASB card. The receipts totaled $1,075. How many of each ticket was sold? Now you know that we're in the section of systems of equations. You know that there are going to be 2 variables. So you need to tell yourself what those variables are and what they mean. So I'm going to use A for ASB, right, for the number of tickets. So if you don't write this out, you're going to get lost in the work, because this tells you how many tickets with ASB, right? If you put A as ASB, you might get mixed up later on in the problem. Is like how much they cost, $5, and you can get all mixed up. So if you tell yourself that this is the number of tickets, you're not going to be able to get lost, and you're going to be able to look at back up here. I'm going to put without is the number of tickets. W is without. Number of tickets sold without an ASB card. So, looking back up here, how many tickets were sold? How can I write an equation with these 2 variables? I know that if I add the number of tickets, A plus W, I'm going to get 200 tickets. This is how many tickets with, how many tickets without, right? That will give me 200 tickets. Now I'm going to have an equation for how much money was collected. Well, I'm going to get to collect $5 for every ticket sold with an ASB card. I'm going to collect $8 for every ticket sold without, and altogether I'm going to collect $1,075. So 5 times the number of tickets with, 8 times the number of tickets without will give me 1,075. So now I'm going to multiply the top one by -5 to cancel one of these out. I could have multiplied by -8 also. And then adding these two together, I will get 3W is equal to 75, or W is equal to 25 tickets without. If I sold 25 tickets without, and I sold 200 tickets altogether, how many did I sell with? Okay, putting it back in here, I will get, subtracting that, I get with ASB, I get 175. Always look back up to see if you answer the question, how many tickets of each type were sold. Okay, so now you need both of these numbers here as the answer. Okay, very good. That's the end, and I'm about to show you the Google form questions because I can't fit the question in the Google form itself. So the Google form question number 1 is this, solve that. Nice simple question. Number 2, solve that. This requires multiplication. Solve that. This also requires a simple multiplication. Solve this one. This one requires a little bit more involved multiplication. And then this one also, okay. This one you're going to, okay. Remember that on these, you're going to give me an x and y, and on this last one, I only want you to solve for x. Okay. And the last one, number 6, 124 cups of lemonade were sold. Large cups sell for 75 cents, and small cups sell for 40 cents. The total collected was $84.95. How many large cups were sold? Remember to answer the question being asked. I'll give you a little tip here. Either do this problem all in pennies, which the 75 and 40 are in, or do it all in dollars. So you might have to put a decimal point in here or take this decimal point out. But be consistent, otherwise your problem will not work out. Okay, that's it.